So first topic for today, and that is the landforms. Okay. While we are studying about the geomorphology is all about the landforms and landscapes which are formed on the surface of the earth. Right? These are the landforms or the landscapes which are formed on the earth. And these landforms, how do these landforms are formed? What are these characteristic landforms? Because there is a concept in geomorphology that each agency leaves its own impact on the rock or the uh, surroundings, right? So each geomorphic agency will develop its own characteristic landforms, right? So we have all these kind of landforms on the earth, right? How which are those mainly the questions are based on the definition type. Okay, what is the definition? And they will give you the definition and will ask you which the landform is defined or which the landform is explained by this definition, right? So this is the simple type of question they can ask from this chapter or from this portion. Okay, so you should be in the position to answer the questions, right? So let us see one by one. The first and the most important type is the river. The most important is river because it is the most extensive and the normal cycle of erosion. Okay, it forms the normal cycle of erosion. I have told you in yesterday's class what is normal cycle. Okay, so the first thing, a valley. Okay, valley. I have given you one example in yesterday's class, the V-shaped valley. Okay, which is formed due to active down cutting. Okay, formed due to active down cutting, right? So V-shaped valleys are formed. The V-shaped valleys are formed, or in a mature stage, the valley widening will be there. In the young youth stage, valley deepening will be there. Okay. Then there is called as there is something which is called as gorge and canyon. Okay, these gorges and canyons are nothing but the valleys themselves. Okay, these are again the valleys, but these valleys are very deep and narrow valleys. Okay, these are deep and narrow valleys, right? Like straight walls or the steep sides slopes. Okay, its side slopes are very steep, almost vertical, right? Almost vertical. So these gorges are smaller and canyons are larger. You might have known or you might have heard about this Grand Canyon. Okay, this Grand Canyon. So what this Grand Canyon is all about? This Grand Canyon is a very large canyon, okay, present in the USA. Okay, Colorado River has developed this Grand Canyon. Okay, and this Colorado River has constructed a very steep valley, and that is the Grand Canyon, which in front of us, right? Basically, these canyons, okay, these canyons are larger features or the larger valleys. Same definition, very deep and narrow valleys with steep side slopes. The slopes are very steep, right? Then comes the waterfall. Okay, the waterfall. Everybody in this class has seen the waterfall once in their lifetime. Okay, any waterfall, say any waterfall. Like you might have seen the waterfalls, you might have seen the larger waterfalls like Niagara or smaller waterfalls anywhere, something else. Okay, nearby Nagpur, there are many waterfalls. Like you can go to this Jabalpur. Okay, Bhedaghat. Okay, you can go to Jabalpur Bhedaghat. So that Bhedaghat will be there. Okay, it is a large waterfall is there, right? So this kind of waterfall, what waterfall actually is, it is a vertical drop of water of enormous volume, a very large amount of volume of water. Okay, very large volume of water uh, drops from a great height. Okay, it drops from a great height. Say suppose this is the river channel. Okay, this is the river channel, and suddenly a depression comes. Okay, suddenly a depression comes. So water will attain very large velocity here. Okay, water will attain a very large velocity, and this large velocity will come on the surface or will come on the floor with again high velocity with enormous volume. Okay, with enormous volume, and this enormous volume or this feature will be called as the waterfall. Okay, now according to the scale, there are different types of waterfalls. If the waterfall or this gradient is very low or very small, it will be called as rapid or cascade. Okay, it will be called as rapid or cascade. If smaller waterfalls are there, like steps, okay, these are like steps, so that will be called as rapid or cascade. Or if larger structures are there, okay, if larger structures are there like this, say uh, 10 meters, 50 meters, 100 meters, it will be called as a waterfall. Okay, it will be called as waterfall, right? Then potholes. Okay, then the potholes. What are potholes is? Pothole is a kettle like small depressions in the rocky beds of the river valley. On a bed of river valley, okay, if this is the bed of the river valley, in this there is something called as swirling action. Okay, the sediments which are flowing in the river, they start moving in a circular fashion. Okay, they start moving in a circular fashion. While they are moving in a circular fashion, right, while they are moving in a circular fashion, they go for drilling action. Okay, so they have velocity, right, they have velocity, and they are moving in this circular fashion like this. Okay, circular fashion like this, and they are down cutting the rock bed. Okay, they are down cutting the rock bed, and they will form a larger depression, smaller depressions. Majority of the times the depressions are smaller, they may get enlarged with respect to time. Okay, as time passes by, the scale of these potholes increases. Okay, large potholes are there. When really large potholes are formed, they are called as plunge pools. Okay, when many potholes get clubbed together and form a very large kind of depression, that will be called as a plunge pool, right? So these kind of features, okay, these kind of features are called as potholes. Okay, these kind of features are called as potholes. So if you get stuck in pothole, it is very difficult to come out of this, because nobody can know about the exact depth of the pothole. Okay, it can be in several centimeters, or it can be in several meters, right? Then river meanders. Okay, river meanders. Meander is nothing but a bend of longitudinal course of the river. These river meanders are formed in the mature stage. Okay, it is forming in the mature stage. Now when the river is in its mature stage, it has low velocity. Okay, it has lower velocity and higher load. Okay, so with the lower velocity and higher load, the river is not an active, or it is not a deadly erosional activity, erosional agency. Okay, it is more of the depositional agency. Okay, so if any kind of obstacle is there, okay, if any kind of obstacle is there, like say suppose a large batholith is there, okay, the river, what will river do? River won't cut the batholith or won't erode the batholith, but simply it will change its course like this. Okay, it will simply change the course. Okay, and this change in course, okay, this change in course and this round which is formed, or this bend which is formed, that is called as meander. Okay, that bend is called as a meander, right? Then Oxbow Lake. Okay, the Oxbow Lake. What is Oxbow Lake? Oxbow Lake is the lake which is formed due to impounding of water in the abundant meander loops. What happens basically, due to this large action? Okay, due to this large action, sometimes it happens that the flooding is there, or prolonged flooding is there, and due to this prolonged flooding, the river attains higher velocity. Okay, river attains higher velocity, so that these feature can be broken now. Okay, this feature can be broken, so river starts flowing in a straight course. Okay, river starts flowing in a straight course like this. So when this river starts flowing in the straight course, this portion, okay, this portion of meander, okay, this portion of meander get cuts off. Okay, gets cut off from the main valley. This is the main valley. Okay, this is the main valley. So this used to be its course. Okay, this used to be its course, but now this course has been changed, and this has now been Okay, this has now been cut off. Okay, this has now been cut off from the main valley or from the uh, main channel, right? Such lakes, this will contain water. Okay, this will contain water, and these lakes will be called as oxbow lakes, or they are also known as horseshoe lakes. Okay, so these are the erosional features of the river. Okay, these are the erosional features of the river. Next we come to the depositional features. Okay, the depositional features, the first depositional feature is the alluvial fan and alluvial cone. Now when river comes on the surface of on the foothills, okay, where abrupt decline in the channel gradient is there, here is the abrupt decline in the channel gradient. The river, okay, river has carried much load. Okay, the river has carried a significant amount of load with it. Okay, river has carried a significant amount of load with it, and this significant amount of load, okay, the significant amount of load, when there is an abrupt decline in the channel gradient, okay, so it cannot carry it any further. So what river will do, it will simply drop the load. Okay, it will simply drop the load here. Okay. And this dropping of the load takes the shape of a cone like this. Okay, it will take the shape of a cone like this, or a fan like this. Okay, that hand fans, right? So these will be called as alluvial cones or alluvial fans. Okay, then natural levees, narrow belts of ridges of low height built by the deposition of sediments by spill water of a stream on either side of the river. Say suppose this river is flowing here. Okay, the river is flowing here and continuously it is flooding river. Okay, it is a flooding river. So that whenever river floods, okay, whenever this river floods, it will spill the water. So it is not like only water is getting spilled. Okay, only the water is getting spilled. It is not like that. The material which is carried by the river will also be spilled here. Okay, will also be deposited here. Now prolonged spilling of water will create a depositional feature here. Okay, it will deposit on the banks of the river. Okay, and it will eventually grow. Okay, it will eventually grow. So this growth will lead to the formation of a natural barrier. Okay, it will lead to the formation of a natural barrier of flooding. Okay, so that the spilling of water does not take place. Okay, the spilling of water does not takes place, and this water will not come out on the surface, or it will not come out on the plains, right? This is the exact, or this is the ideal condition for human settlement. Okay, this is the ideal condition for human settlement, and majority of the ancient cities in the world, they are, or many of the ancient civilizations in the world, they are situated near the banks of the river. This is the reason. Next, delta. Delta is the depositional feature of almost triangular shape at the mouth of the river. When river meets sea or any larger lake, okay, river meets sea or any larger lakes. So this is a sea, okay, and river is coming from here. When sea activity are calm and quiet, okay, when sea or the marine activities are not that pronounced, what will happen, the river will deposit its material in a triangular shape. Okay, river will deposit its material in a triangular shape, and these kind of deposits, they are called as deltas. Okay, these kind of deposits are called as deltas. Okay, so where it is formed, it is formed at the mouth of the sea, mouth of the river. When river meets a sea or a large lake. Got this? So this is all about river. Okay, this is all about the geological action, or these landforms which are formed due to the action of river. Next comes the groundwater. Okay, the groundwater. Now, groundwater has the erosional tendency. Okay, it has the erosional tendency, but the major actions, okay, the major phenomenon by the groundwater erosion is by chemical weathering. Okay, it is by the chemical weathering. It is groundwater does not act as the mechanical agent. Okay, like river, like ocean, or like wind. Okay, but it is more on a chemical weathering, right? So the first erosional feature which is formed is lapis. The lapis is highly corrugated and rough surface of limestone characterized by low ridges and pinnacles. It actually looks like this. Okay, this is actually underground. Okay, this is actually underground. Okay, so in a limestone, okay, in a limestone, if the rough surfaces are there, corrugated surfaces are there, which are characterized by lower ridges, okay, lower ridges and grooves. Okay, so these will be called as lapis. Okay, that will be called as lapis. Okay, next comes solution holes. Okay, the solution holes. Now in the solution holes, what happens is, okay, rainwater which is chemically active. Okay, rainwater chemically active, that means rainwater plus atmospheric carbon dioxide. Okay, rainwater plus carbon dioxide. When such solution comes in contact with the carbonate rocks, okay, it starts to dissolve the rock. Okay, it starts to dissolve the rock. So say suppose this is the rock. Okay, this is the rock, and such chemically active rainwater is dropping on the surface. Wherever the drops are coming continuously, it will start to dissolve that rock. Okay, it will start to dissolve the rocks, the portion of the rock, and this will be called as the solution hole. Okay, it will be called as a solution hole because due to solution the material has been removed off and only one cavity has left. Okay, a cavity has left there, and that cavity is called as a solution hole. So it can be cylindrical in shape or it can be conical in shape. Okay, these are two shapes which are available or which are observed in the solution holes, either cylindrical or conical. Okay. Then swallow holes. Swallow holes are nothing but larger solution holes. When these solution holes become larger, that means say this is one solution hole, this is one solution hole, and this is one solution hole. So eventually these solution holes will grow. Okay, these solution holes will grow and will coalesce, will collide with each other. Okay, it will collide with each other and will form. Okay, they will form a large solution hole like this. Okay, they will form a large solution hole like this. So this will be called as a swallow hole. Okay, this will be called as swallow hole. When this process becomes continuous, okay, when this process goes on occurring, it will become even larger, more even larger this hole. Okay, this will be called as dolly. Okay, this will be called as dolly. Still we are in underground areas. Okay, we are in the underground areas. All this action is happening underground. Okay, now it it forms like if the upper surface of the sinkhole or dolly, okay, this is the upper surface of sinkhole or dolly, collapses. Okay, it collapses, so the internal structure or this internal feature gets uh, exposed on the surface. Okay, it will get exposed on the surface, and this exposure, okay, this exposure will be called as a karst window. Okay, this will be called as karst window. Okay, uvalas are extensive depressions up to 1 kilometer in size. So these karst windows, if they are up to 1 kilometer in size, they will be called as uvala. Okay, they will be called as the uvala or uvala, whatever you want to prefer, want to call it, right? Then caves. Okay, caves. What are caves? Caves are the voids of larger dimensions below the ground. These are also called as caverns. Okay, caves or caverns, whatever you want to call it, right? So these are the voids of larger dimensions inside the ground. Large caves are there. Okay, larger caves, larger dimensions are there. Some years ago, there were some kids or some sports, some kids from the school in Indonesia. They were lost in these caves, the limestone cave, right? So these caves are of these huge dimensions. Okay. The depositional features. Okay, the depositional features. The depositional features include stalactite, stalagmite. Okay, stalactite and stalagmite. What is stalactite? When the water, okay, when this carbonate rich water or calcareous solution, okay, when this calcareous solution drops inside the cave, okay, drops inside the cave from the ceiling, okay, from the ceiling, and it grows downwards. Okay, grows downwards means grows towards the base or grows towards the floor. Okay, this will be called as stalactite. Okay, this will be called as stalactite. And what is stalagmite? The opposite to this, when this water will drop on the floor. Okay, the water will drop on the floor and it will grow from the floor towards the ceiling. Okay, from the floor towards the ceiling. This will be called as stalagmite. Okay, that will be called as stalagmite and stalactite. If these two, stalactite and stalagmite, meet somewhere, okay, during their respective growth, okay, during their respective growth, if such structures are formed, it will be called as cave pillars. Okay, this will be called as the cave pillars. Simple. Okay. Next, we are heading towards the third agency, and that is ocean. Okay, the third agency, which is ocean. Now, ocean is not that active agent. Okay, it is not that active agent of erosion or of erosion. Basically, it is more for deposition. Okay, but ocean has also formed some of the features. Okay, it has also formed some of the features which are remarkable to see. Okay, the first one is the cliff. Cliff is a steep rocky coast rising almost vertically above the sea level. Okay, it is like this. Here there is sea. So rising almost vertically about around the sea level. So this is called as cliff coast. Okay. This is called as a cliff. Okay, sea cliff. That means actually what is the mechanism here? It used to be like this. Okay, it used to be like this. Now the sea action is there. Okay, the sea action is there. So the waves, okay, waves are active erosional agents. Okay, waves are the actual erosional agent, active erosional agents. So by the time these waves have acted upon on this cliff or on the rock, okay, and then it started receding. Okay, it started receding or recession. This process is called as cliff recession. That means earlier the cliff was here at point A, and now after say 50,000 years, okay, or 1 lakh years, it is at point B. Okay, it is at point B. So this distance, okay, this distance of say 50 meters or 100 meters, okay, 50 meters, 100 meters, or even 10 meters, okay, this distance which is covered by the rock or this cliff, is the cliff recession. Cliff recession, that means the backward movement of the cliff. Okay. Next is the wave cut platform. Okay, this wave cut platform. The wave cut platforms forms where cliff recession is active. Okay, cliff recession is active due to powerful bombardment of cliff base by approaching breaker waves. Okay, so where will it form? The wave cut platforms will be formed here. Okay, at here, at this area. Okay, the waves will strike that area. Okay, the waves will strike that area. So the caves or the wave cut platforms forms like this. Okay, now the sea arches or chimneys. Okay, sea arches or chimneys. Okay, now what happened here is sea is again a chemical agent, a chemical weathering agent. Okay, chemical erosional agent. If suppose there is this rock inside the sea. Okay, this is rock inside the sea. From all the sides there is a sea. Okay, from all the side there is a sea. Now what happened here is that this is complete massive rock. Okay, this complete is a massive rock. Due to action of the sea, a small cave has been formed. Okay, a small cave has been formed here, and another cave has been formed in the backside as well. Okay, another cave has been formed at the backside as well, right? Okay, imagine this as a three-dimensional structure. Okay, imagine this as a three-dimensional structure. Now from this side there is a cave, from another side there is also a cave. Okay, I'll indicate the sea by blue so that it will be easier for you to understand this. Okay, so this is the sea here. Okay, this is the sea here, and here what is occurring is the chemical erosion or chemical weathering. So from this side, side A, there is erosion. From backside, the side B, there is also erosion. Now these two caves or these two holes, they are coming together and meeting at the midpoint where the water, okay, where the water can actually cross the feature. Okay, it can actually cross the feature, and this feature actually grows. Okay, this feature eventually grows like this. Okay, this feature actually grows like this, and eventually it forms. Okay, eventually it forms a large feature like this, which is called as, which looks like an arch. Okay, which looks like an arch, and hence it is called as natural arch or sea arch. Okay, hence it will be called as a sea arch. These are very beautiful structures to see. Okay, very beautiful structures. You might have witnessed or you might have seen these structures in many of the film songs. Okay, many of the film songs you will see this natural bridges, natural sea arches or natural arches. Right, now what happens, what happens next is this structure goes on increasing and increasing. Okay, the structures goes on increasing, so it becomes so thin. Okay, after some time it becomes so thin that this roof collapses. Okay, it does not remains uh, that strong throughout the life. Okay, the roof get collapsed. Okay, roof get collapsed, and only this portion is left. Okay, only this portion is left. Okay, this is called as natural chimneys. Okay, this portion is called as natural chimneys. Only the side portion, okay, only the side portion or the limb of the natural or the sea arch. Okay, only the limb of the sea arch. That will be nothing but your natural chimneys. Okay. So these are the erosional features of the ocean. Okay, these are the erosional features of the ocean. Now comes the depositional features of the ocean. Okay, depositional features of the ocean. Now depositional features, they are very beautiful to see. You might have witnessed this, or you might have visited even these kind of features. Okay, you might have visited these kind of features. Okay, the first one is the beach. Okay, is a beach. Many of the people like to go and visit and see or play on beaches, right? What beaches actually are? Beaches are temporary deposits of marine sediments consisting of sand, shingles, cobbles, etc. on the seashore. On wherever the seashore is, whatever the materials are being deposited, okay, whatever the materials are present, they are getting deposited. It might be sand, might be shingle, it might be cobble. Okay, on the seashore, whatever the sea is uh, getting on the surface, or whatever the sea is getting on the shore, okay, that will get deposited. These are nothing but the sizes of materials: sand size material, shingle size material, cobble size material. Okay, remember this or recall this wooden Wentworth grade scale, which I have told you, okay, in the classification of sedimentary rocks. Okay, so these kind of materials will be deposited on the seashore. Okay, this will be deposited on the seashore, and these materials, okay, these materials or these type of depositional features, they are called as beaches. These are temporary material, temporary deposits, because they are either growing or they are either eroding. Okay, if the sea action is large, okay, if the sea action is large, the beaches are eroding. That means the beaches are getting destroyed. And if the sea action is not that erosive or that larger, it will be growing beach, right? This is the part of actually sequence stratigraphy. Okay. Next comes the bars and barriers. Okay, the bars and barriers. Now bars and barriers, they are basically the same features. Okay, basically similar features, just there are small differences. Okay, so first one is the bar, that is the ridges, embankments or mounds formed by the sediments through sea waves parallel to the shoreline. Okay, this is sea, this is the shoreline. Okay, this entirely is a sea. Okay, this entirely is a sea. Now parallel to shoreline, there are several mounds. There are several mounds which are cropping out of the water. Okay, cropping out from the water. Sea has deposited its material. Okay, sea has deposited its material, and this material has been deposited so high. Okay, the material has been deposited so high that it is now cropping out on the surface, on the water surface. Okay, and it acts as the basically the preventive measure. Okay, preventive measure for the coast. Okay, preventive measure for the coast or the shoreline. Okay, so this is called as a bar. Okay, this material or this kind of feature is called as a bar, right? Now, barriers are larger forms of the bars. If you enlarge this, okay, if you enlarge this for few say hundreds of meters, it will be called as a barrier. Okay, spits are nothing but the bars. Okay, spits are nothing but the bars, but they are formed like this. Okay, they are formed like this. Okay, their one end is attached to land. Okay, its one end is attached to land, another end is open into sea. Okay, another end is open into the sea, right? So such kind of materials or such kind of deposits, they are actually the spits. Okay, now sometimes it happens due to sea action, these spits get curved. Okay, the spit gets curved. Okay, these kind of curved spits, which takes the shape of a hook. Okay, which takes the shape of a hook, will simply be called as hook or hooked spit. Okay, now Tambolo. Tambolo is is a bar. Okay, it is actually a bar which connects. Okay, which connects the island. This is the island with mainland. Okay, which connects one island with the mainland. Sand deposit is there. Okay, a sand deposit is there which connects an island with the mainland. Okay, so that will be called as Tambolo. Okay, that structure or that feature is called as a Tambolo. Okay, next agency which we have to look for is the wind. Okay, now again, wind is a weak agency. Okay, wind is a weak agency. It is not that strong agent of erosion. Okay, but it goes for erosion in significant way. Okay, the first landform is the pedestal rock, which is also called as mushroom rock. Okay, rocks with broad top and narrow base, something like this. Okay, something like this, right? Why is it so? This was originally like this. This rock was originally like this. It was acted upon by the wind. Okay, it was acted upon by the wind, and this wind action, okay, this wind action has significantly reduced. Okay, it has significantly reduced the base of the rock. Okay, it has significantly reduced the base of the. This is why, why this base only has been eroded, because wind is a weak agent. Okay, wind is the weak agent. It does not or it cannot carry larger materials at the topmost level. It will carry the material on the basement level. Okay, and hence the erosion or the more intense erosion will be at the base level. Okay, it will be at the lower level, and hence the lower level of the rock will be eroded more than that of the top. Okay, it will be eroded more than the top, hence this top becomes flat and it becomes narrow. Okay, next is Zeugens. Okay, Zeugens, the rock masses of tabular form resembling a capped ink pot, just like this. Okay, these are the landforms which are formed like this. Okay, a capped ink pot like structures are there. Wind comes and swirls like this. Okay, and due to this, these Zeugens are formed. Okay, remember this ink pot. Okay, a capped ink pot. Just remember this and it will be done. Right, yardangs. Yardangs are the steep-sided, deeply undercut, overhanging rock ridges separated from one another by long grooves. Something structures like this. Okay, structures something like this. They are these kind of parallel structures in which the internal material has been removed off. Okay, the internal material has been removed off or undercut. These overhanging rocks. Okay, these overhanging rocks, they are separated from one another and they are standing intact. Okay, they are standing intact. So the incompetent rock or the softer rock has been removed off. Okay, the softer rock has been removed off, and the harder and the competent rock is remaining in the parallel arrangement, and this will be called as the yardang. Okay, this will be called as yardang. Okay, next is the depositional landforms. The depositional landforms, very easy depositional landforms are there. Okay, the sand dunes are heaps or mounds of the sands like this. Okay, like this. This is nothing but the sand dune. Okay. Okay. This is nothing but the sand dune. So these sand dunes will grow, they will migrate. Okay, sand dunes will grow, they will migrate, and they will give you uh, one of the most striking and beautiful features if you ever go to Rajasthan. Okay, this Marwad, Jaisalmer, Jodhpur, those sides. Okay, you will come to know or you will come to see this kind of sand dunes. Okay, smaller, larger sand dunes you can see. Okay, in the Thar desert. Go to the Thar desert. Okay, then longitudinal dunes. These longitudinal dunes are those in which the sand dunes which are formed parallel to the wind direction. Whatever the wind direction is, say this is the wind direction, the sand dunes will be formed like. Okay, there might be some of the obstacles. Okay, there might be some of the obstacles. These will restrict the movement of this sand, and along in the parallel way. Okay, in the parallel way there will be the formation of the sand dune, and this will be called as a longitudinal dune. Transverse dune, opposite to that of the longitudinal dunes. Okay, transverse dunes, they are formed transverse or perpendicular to the direction of the wind. Okay, Barkhan is a type of dune. Okay, Barkhan is a type of dune which is a crescent shaped dune. Okay, which is a crescent shaped dunes which has two horns. Okay, a crescent shaped dunes which has two horns, right? Like this. So this will be Barkhan. The last agency which we have to see today is the glacier. Okay, this glacier. Now, again, this glacier develops its own valley, as there are schools of thought. Okay, there are these schools of thought that glacier develops its own valley, or there is one another school of thought glacier does not uh, develop its own valley. Okay, it just modifies the pre-existing river valley. So both the views are in practice. So you can follow anything, right? So U-shaped valleys, flat-based valley formed by glacier. It is essentially like this. Okay, this is the striking difference. Okay, this is the striking difference between the U-shaped valley and the V-shaped valley. That is the river valley and glacial valley. River valley is always V-shaped valley, and glacial valley is always U-shaped valley. Okay, so it will be a flat based valley. Okay, then hanging valley. Hanging valley means there is, says this is the valley. Okay, this is a U-shaped valley. This is a U-shaped valley which is flowing, and tributary, just like the tributaries of the rivers, there are the tributaries of the glaciers. The tributaries, they are joining from larger heights. Okay, they are joining from the larger heights, say from a mountain. Okay, like this. Okay, like this. So this will be called as a hanging valley. Okay, this will be called as the hanging valley. So it is coming from the larger height, and joining to the main valley or main glacial valley which is at the greater depth, right? This will be called as hanging valley. Okay. Cirque, steep wall depression representing glacial valley head. A steep wall depression like this. Okay, if this is the path of glacier, okay, this is the path of the glacier. This is a steep valley face. Okay, steep valley face or steep valley head. In the yesterday's class, I have given you the parts of the slope. Okay, an ideal slope. So this is convexity. Okay, convexity. Then free fall. Okay, free fall or vertical shape. Then rectilinear, and then basal concavity. So these shape, okay, this part or the steep slope can be considered as the, okay, this can be considered as a cirque. Tarn, the rock basin formed at the floor of the cirque basin at the cirque. Okay, just like in the slope, there was in the at the basin at the base of the slope there was basal concavity. Okay, there was basal concavity. So this basal concavity is nothing but a depression, right? This is nothing but a depression. So same depression will be found, or same depression will be formed at the base of this cirque. Okay, the base of the cirque. This will be called as tar. Okay. Now there is something called as Nunatak. Nunatak is higher peaks and mounds surrounded by the ice from all the sides. So say this is the peak or this is the mountain. This was a mountain, and now this mountain is surrounded from all the sides. Okay, this mountain is surrounded from all the sides by the ice. Okay, it is surrounded from all the sides by the ice. So only one peak or a small peak is left. Okay, only a small peak is left. So this peak will be called as, okay, this will be called as Nunata. Okay. Next comes the fjord. Okay, nowadays this spelling is in practice. Okay, fjord or jord, whatever you want to pronounce it. Okay, so these are nothing but the glacial troughs occupied by the sea. That means the glacial valleys. Okay, fjords are nothing but the glacial valleys in which the sea water has been intruded. That means the glacier has reached its base level of erosion. Okay, the glacier has reached its base level of erosion. When the glacier reaches the base level of erosion, the sea intervenes. Okay, the sea water intervenes or sea water intrudes and takes the charge of the valley. Okay, it takes the charge of the valley, and this valley, okay, this valley, this kind of trough is called as fjord or fjord, whatever. The last thing is the depositional landforms, and these are very much important because these are confusing. Okay, so it is moraine, ridge-like depressions of the deposits of the glacial tills. Okay, whenever the glacial tills are getting deposited, okay, wherever the glacial tills are getting deposited, those deposition will be called as moraines. Okay, so there are types of moraines. The first one is the end moraine. Okay, the first one is the end moraine. Say suppose this is a glacier which is flowing. Okay, and this has deposited the tills here. Okay, at the end of the glacier, okay, at the end of the glacier where actually the ice has started to melt. Okay, where the ice has started to melt. Now from here, from this point onwards, the ice will melt. There won't be any glacier. It will convert to a stream, right? So wherever this kind of structure, okay, wherever this kind of structure has been developed, it will be called as end moraine. Okay, it will be called as end moraine, or it has one more name that is called as terminal moraine. Okay, this will be called as terminal moraine, right? Now there is something which is lateral moraine. Okay, lateral moraine, as the name itself indicates, lateral means on the sides. Okay, when such deposits are there which are found at the sides or the parallel sides on either sides of the glaciers, it will be called as lateral moraines. When two glacier meet, okay, when two glaciers meet, this is one glacier, this is another glacier coming from here. Okay, coming from here, and it is also depositing a moraine, it is also depositing a moraine. So these internal moraines, okay, these internal margins of the glaciers, they come along and form a large amount of moraine. Okay, this will be called as medial moraine. Okay, this will be called as the medial moraine. And when the sediments are accumulated on the floor of the glacial valley, okay, when they are deposited at the floor of the glacial valley, it will be called as ground moraine. Okay, they will be called as the ground moraine. So this is the classification of the moraines. Okay, and their depositional features which are formed due to the glaciers. Okay, so this is it about the uh, features or the landforms which are formed due to geomorphic agents. Got this? So if you have any questions regarding the landforms, this portion, whatever I have given you the account till now. Okay, I'll cover one more topic, and that is the last topic for today and for this syllabus. Okay, that is the groundwater province, this physiography of Maharashtra. Okay. The physiography of Maharashtra and river systems. So, is my screen visible to you?
Yes, sir.
Okay. Again, I have taken this from the government document. Okay. Sarkari document. You can take it. You can read it. I have uploaded this on the app. Okay. That hydrological provinces. Okay. Hydrological provinces of Maharashtra. That PDF. This is the same PDF. Okay. So physiography and drainage. So physiographically, the state can be divided into three units. We have the Sahyadri range, Western Ghats, the Western Coastal Tract, which is the Konkan area, and the Eastern Plateau, which is the Deccan Plateau. Okay. So physiographically, as like India has been divided into three parts: peninsular, extra-peninsular, and Indo-Gangetic plains. Okay. State of Maharashtra has been divided into three regions. Okay, or three units: the Sahyadri range, the coastal tract, and the Eastern Plateau. Okay. So Sahyadri range will be called as Western Ghats. The Western coastal tract will be called as Konkan, and the Eastern Plateau will be called as the Deccan Plateau. Okay. Or it will also be called as Maharashtra Plateau. Okay. Sahyadri range. The first is the Sahyadri range. The Western Ghats of Maharashtra is called Sahyadri mountain. Okay. It is called as the Sahyadri mountain. It has the average elevation of 1000 to 1300 meters above mean sea level. Okay. The Western Ghat is a mountainous tract with the western escarpment face the eastern denudation slopes. Length of the Western Ghat is 1600 kilometers. Okay. The Sahyadri hills run parallel to the sea coast with many offshoots branching eastwards from the main ranges. So the ranges we have is Satmala, Ajanta, Harishchandra, Balaghat, and Mahadev. Okay. The largest and the highest peak is Kalsubai. Okay, highest peak in Maharashtra is Kalsubai, which has the altitude of 1650 meters. Okay, special features: the Trambakeshwar, Matheran, and the Mahabaleshwar plateau. These are the hill stations in Maharashtra. Okay, so most of the rivers in Maharashtra originate in the Sahyadris and then divide to join the eastward and westward flowing rivers. Okay. These ranges are also characterized by a number of ghats, the important ones being Thal, Bor, Kumbharli, Amba, Khonda, and Amburi. You can forget this or you can overlook this. Okay. Okay, this is complete data. Next is the Konkan coastal strip. Okay, the Konkan coastal strip. The narrow strip of coastal land between the Sahyadri and the Arabian Sea is called as the Konkan coastal strip. Okay, Sahyadri, Arabian Sea. In between these, that there is called as Konkan coastal strip. So the Konkan tract runs almost 500 kilometers north to south with the width varying 30 and 100 kilometers. It is wider in north and narrower down the south, and the elevation ranging up to 350 above MSL. Okay. Next comes the Deccan Plateau or the Maharashtra Plateau. So Deccan Plateau occupies the rest of the state. As we know, 82% of the state. Okay, 82% of the state is carried as is covered by Deccan Plateau. Okay, so Deccan Plateau can be subdivided into number of well-marked elevation ridges, lower elevation valleys. The eastern part covering Gondia, Bhandara, Gadchiroli, Chandrapur, Nagpur, and Wardha district are occupied by narrow alluvial plains of Wainganga, Penganga, and Wardha rivers and has the maximum altitude above MSL up to 300 meters. The alluvial plain of Tapi Purna River Valley with east-west trend and maximum altitude of 300 meters MSL occupies the northern part of Amravati, Akola district of Vidarbha, and Jalgaon, Dhule, Nandurbar district of Khandesh. Okay, so which river carries which kind of deposit or which kind of river is draining in which area? This becomes important part here. Okay. The remaining part of the plateau is occupied by the valley of Godavari, Bhima, and Krishna rivers. altitude of these plains range from 300 to 600 meters. In general, the altitude of the plain increases from east to west. Okay, the hill ranges traversing in plateau are Satmala Ajanta range, the Harishchandra Balaghat range, and Mahadev range. Okay, so these ranges are connected to the Western Ghat in the west. Okay, their altitude ranges between 600 to 900 meters above MSL. See, in this portion, there is nothing like which is I should explain or I should uh, make you understand. This is just the data which you have to mug up. Okay, and next comes the drainage pattern or the river systems in Maharashtra. Okay, the river system in Maharashtra. So in Maharashtra, we have different types of rivers. Okay, so the major rivers in Maharashtra is Godavari, Krishna, Tapi, and the Konkan rivers. So they drain Maharashtra state from four distinct river basins. So these four distinct river basins are Krishna, Godavari, Tapi, and Narmada. Okay, so the Godavari river basin, you can overlook this number. It is not required. Okay, can be subdivided into Vainganga, Penganga, Vardha, and Godavari river subbasins. So these are the four subbasins. Okay, these are the four subbasins of the river Godavari river basin. Right. The Krishna basin can further be subdivided into Krishna, Bhima, and Sinaman river. Okay. Then Tapi basin can further be subdivided into lower, middle, and upper sub basin, and Narmada basin in Maharashtra state. Okay, the coastal basin occupies 491 square kilometer in the union territory of Dadra and Nagar Haveli. Okay. About 75% of Maharashtra, okay, about 75% of area of Maharashtra drained by the eastward flowing rivers, that is the Godavari and Krishna. Remember this. Okay, remember this. Which river flows eastward and which river flows westwards, right? So these Godavari and Krishna go towards Bay of Bengal. Okay, Godavari and Krishna go towards Bay of Bengal. Okay, and the remaining 25% area is drained by westward flowing rivers, that is Tapi and Konkan river. Okay, this Tapi and Konkan river, they flow towards Arabian Sea. Okay, so this 45% of state's water resource are from west flowing rivers. Okay, these are from the west flowing rivers, that is the Tapi and Konkan. Okay, the Tapi and Konkan. These are which are mainly monsoon specific rivers emanating from the Ghats and draining into Arabian Sea. So these rivers, this Tapi and Konkan river, they go towards Arabian Sea. Godavari and Krishna go towards Bay of Bengal. So if the question setter want to confuse you, okay, if he wants to confuse you, he won't give you these names, Godavari, Krishna. Okay, he will ask you which of the following are the eastward flowing rivers. Okay, and there won't be any name like Krishna and Godavari. Which names can be there? There shall be Vainganga, there may be Penganga, there may be Vardha. Okay, there may be Bhima, there may be Sinaman. Okay, so these kind of questions, this kind of jugglery can be done. Okay, this kind of jugglery can be done. Right. So question paper setter can set any kind of question. Okay, be clever to answer this. Right, be clever in answering such kind of twisted questions. Okay, so this is it for today.